Here we have a function, natural logarithm of x squared plus y, and we're going to be taking first and second derivatives of it. So this is just a function of a function. So to take df by dx, I differentiate the function first. So that just gets me 1 over x squared plus y. And now I differentiate the argument of the function, and that gets me 2x. Similarly, I can take the y derivative, df dy. So again, first I differentiate the function, x squared plus y, and now I differentiate the argument of the function with respect to y, and that just gets me 1. Now to take second derivatives, I'm going to need, at least for df dx, I'm going to need the quotient rule, which is that d by dx of u over v is v du dx minus u dv dx all over v squared. So if I calculate d2f dx squared, which is d by dx of df dx, 2x on x squared plus y, then u is going to be 2x and v is going to be x squared plus y. So now I can use a quotient rule to work out the derivative. So v times du dx, v is x squared plus y, du dx is just 2, so we subtract a u, that's 2x, and multiply by dv dx, that's 2x again, and then divide through by v squared, x squared plus y, all squared. So now we just need to tidy this up a bit. So I'll multiply out the top. So that's 2x squared plus 2y minus 4x squared all over x squared plus y, all squared. I can simplify the top some more. So 2x minus 2x squared minus 4x squared, that's just minus 2x squared. So we end up with 2y minus x squared all over x squared plus y, all squared. The next thing to do would be to take the cross derivative, d2f dy dx, so that's d by dy of df dx, so that's 2x over x squared plus y. Now remember, I'm treating x as a constant because I'm differentiating with respect to y. So I can tie this up a bit more. So this is d by dy of 2x, which is I'm just treating as a constant, times x squared plus y to the power minus 1. So now again I can use a chain rule. The 2x just sits there. Then I differentiate the function of a function. So I bring down the minus 1. And then we have x squared plus y to the power minus 2, because I reduce the power by 1. And then I differentiate the argument of the function, x squared plus y, with respect to y, which just gets me 1. So d2f dy squared, that's just minus 2x over x squared plus y all squared. Now I also need to calculate the second order derivatives with respect to y. So we'll start with d2f dy squared. So that's d by dy of df dy, and that's just 1 over x squared plus y. So I'm going to write this in a form I can use the chain rule on. So that's d by dy of x squared plus y to minus 1. Now I can differentiate this very easily. I bring down the power. Subtract 1 from the power, 2, and then multiply by the derivative of the argument x squared plus y with respect to y, which is just 1. So tidying that up, I get 1 over x squared plus y all squared. So a final thing to calculate is the final cross derivative, d2f dx dy. So that's d by dx of df dy. So that's x squared plus y to the power minus 1. So yet again I use a chain rule. So I bring down the minus, x squared plus y to the power minus 2, and again multiply by the derivative of the argument, which in this case will be 2x. So finally I get minus 2x all over x squared plus y squared, which is the same as we had for the other cross derivative.